Hi everyone, today we're going to be talking about special similar triangles. So in the last video, we talked about how to solve similar triangles to determine if they're similar or not. And in this one, we're just using a few different shapes. They're all still triangles, but they're kind of set up in a little bit different ways. So we want to make sure that we have the right setup. But they are solved the same way with setting up two fractions and then using cross multiplication. So let's go ahead and get started. The first example is these two triangles that are set right next to each other, and the goal is to solve for x. So what we need to do in these cases, and I know I'm not the best artist, but you can look at the picture that you have on the example sheet, but what we need to do in these cases, or the easiest way to start these, is to kind of separate the two triangles. That way we can look at them and determine which sides are the similar sides. So I'm going to make one triangle like the red triangle, and then the other triangle the blue triangle. And then what we're going to do is flip them around so that they are set up exactly the same way but separated. So I'm going to start with the red triangle. And I'm just going to draw it right over here. So let's have this be G, this be F, and this be Q, which means that this is X plus 3, and this is 15. Then I'm going to draw the blue triangle, and the blue triangle looks really similar, obviously. So I'm going to see if I can draw it over here. I know it's not going to be the same size because we're running out of space on the side. But so this is where you need to really kind of be thinking how these triangles flip. Now, normally what happens is that this side right here, this one with the 15, is equal to this side right here, the one with the 35. So, excuse me, it's almost like we flip around the blue triangle. So this side is going to be, let's see, R, Q, and S, which means this is 35 and this is 35. Now, in this case, it doesn't actually matter that we flipped it around because both sides ended up being 35. But in the other cases where they're not the same number, it is important. So you want to make sure that you do flip those things. So now that we have the two triangles and they're set up in the same way, we can decide which sides are similar. Excuse me. And I know I've already used my red and blue, but think about like this side has to be similar to this side. They're both on the left. And then let's use yellow. This side has to be similar to this side because they're both on the right. And because the way that I set up the triangles, I can just use left and right. So now I can actually set up my two fractions, and my green fraction, in fact, yeah, let's use green, would be X plus 3 over 35 if I did the left triangle over the right triangle. And then my yellow fraction is going to be 15 over 35. And because they've told us that these are similar, we can set them equal to each other so that we can solve for x. So now we have two fractions that are set equal to each other. In order to solve, we're going to cross multiply. So to cross multiply, we would have 15 times 35, which is this one right here, is equal to this one right here, which would be 35 times x plus 3. Okay, so now I'm going to go grab my calculator. And we can do 15 times 35, which is 525. And then the 35 on the right side will be distributed. So 35 times x gives me 35x. And 35 times 3 gives me 105. Now to solve for x, I want to get the x by itself. So I'm going to subtract 105 from each side. Excuse me. And I get 420 equals 35x. Still want to get x by itself, so I'm going to divide each side by 35. and I get 420 divided by 35 is 12, which means that x is equal to 12. And there we have it. That's our answer. So all of this stuff we've actually done before in previous self-checks. It's just now they're slightly different shaped, or they're set up in a little bit of a different way. And so the whole cross multiplication thing and setting up the fractions should be easy for you. It's just setting up the triangles that's new. Okay, let's look at the second example. So in the second example, it's like we have a triangle inside of a triangle. So we're going to make one triangle. We'll make the smaller triangle the red triangle, and then the bigger triangle the blue triangle. Now they overlap, and that's okay. We just want to make sure that we have two triangles that we can set up. So I'm going to start by drawing our red triangle, which is CPQ. And we know we have 36 right here and 28 right here. Now, we don't necessarily know the bottom because they didn't give us a number for the bottom. But we will talk about how to get there. And then let's do the blue. So the blue triangle is CED. And we know this side is 91. We know, so for the blue triangle, the lines with the arrows are what we're looking at. So this side is 117, and then this side is 13x. Okay, so this is a little bit different because you don't have the bottom of the red triangle. But what we can do on here is figure out what we're multiplying by every time, and then that doesn't make sense. Oh, I'm sorry. I'm so silly. When I wrote it out, I just didn't put the 24. You guys were probably thinking that I'm crazy. So this is 24. Now we can actually go through and do it. So when we do this, we have all three sides on each triangle. We want to use the side with the x, so that's the bottom side. So I'm going to make the bottom side the green side. And then it doesn't matter which one we use for the other one, whether we use the right side or the top side, it doesn't matter. Or for the yellow, I'm sorry. So I'm just going to use this side. It's 98 over 21. Okay. So let's set them up. The green fraction would be 24 over 13x. And the yellow fraction would be 28 over 91. And because we know they're similar, we're going to set them equal to each other, and then we can cross multiply. So we're going to have 24 times 91 equals 28 times 13x. And now we just have to use our calculator. We're going to figure out what 24 times 91 is, and that is 2,184 is equal to 28 times 13x. So 28 times 13 is 364x. Okay, so we want to get the x by itself, so we're going to divide each side by 364. And when I plug that into a calculator, I end up with the x is equal to 6. And that's how we solve that similar triangle. Okay, so the third example isn't necessarily a triangle, it's just a bunch of arrows, but it does come in the shape of a triangle. So we can still set it up this way. Now, there's a couple of different ways that we can set this one up. If you had everything, like, you could actually do like this chunk and this chunk, like you could set those up, and I know they're not triangles, but it could work. It would work, but you'd have to have like the sides set up and everything, and potentially we could find this side right here, because we know that the whole side is 27 and then the portion on the top is 15, so I could do 27 minus 15 to figure that side out. But on this side over here, I would also need that part in order to set up my fractions. And while I could do it, it is going to be a little bit tricky. So instead of doing it that way, what I'm going to do is use like the bigger triangle and the littler triangle, kind of like what we did in the last case. So I'm going to use like this is a triangle, and then, oh, sorry, this whole one as a triangle. And I know I'm kind of cutting off the top right there. It's because it's not really a triangle because of that parallel line at the very bottom, but it still works out the same way. Okay, so now let's redraw them. For the red shape, we should have something like this. And we know this side is 16. And then on the left side, we kind of talked about it, but we can do 27 minus 15 to figure out what that side is. And 27 minus 15 is 12, so I know this side has to be 12. Now let's draw the blue shape. And we know that this left side has to be 27, and then the right side is 6x minus 6. Okay, so now they're set up. We can do our green side and yellow side. Our green side can just be the left side, and then our yellow side can be the right side. So many colors in this video. Okay, so our green fraction would be 12 over 27, and then our yellow fraction is 16 over 6x minus 6. We can set these things equal to each other because they're similar. Now we can cross multiply. So I'm going to end up with 27 times 16 is equal to 12 times 6x minus 6. Now let's do some math. So we're going to do 27 times 16, which gives us 432. And then we're going to distribute the 12. So we'd have 12 times 6x, which gives us 72x, because 12 times 6 is 72, minus 12 times 6, which also gives us 72. Now we're going to add 72 to each side, which gives us, oh, I subtracted 432 plus 72, 504. 72x, and then we're going to divide each side by 72, which gives us 7. So I know that x is equal to 7. All right, let's do one more example, and I'm going to kind of move it down a little bit because I got all up in its space with that last example. Okay, so this one, when you have a triangle and you split the angle like this, you have to use it, like the red triangle has to be, one of the triangles has to be the triangle on one side, and then the other triangle has to be the triangle on the other side. While they don't necessarily look the same, it will work out this way. Like it will work out, you can use it this way. So I'm gonna redraw the red triangle. Once again, I'm not an artist. And this would give us 10 and 4. We don't know what that other side is. It didn't tell us. And then our blue triangle, we know this side is 15. And then the other side on the bottom, we don't necessarily know what the bottom blue part is, but we do know that the entire bottom is 2x minus 6. So what we're going to have to do on the bottom of the blue one is if the entire thing is 2x minus 6 and then the red part is 4, to find the blue part, I would do the entire thing minus the red part. So it's kind of like 2x minus 6, because that's the entire thing, minus the red part, which is 4. And I can put that on the bottom of the blue one. I can actually also simplify it and just combine the minus 6 and minus 4 to make it 2x minus 10. So that's the blue part, this 2x minus 10. So I'm going to make it 2x, that was a weird x, let's try that again, minus 10. Okay, so now we can do our red and, or our green and yellow. So let's make our green the top part. Oh, now, okay, this another thing before I lose myself. Obviously, you have the left side of one triangle and the right side of another triangle. Because of the way that this is, and we're splitting the angle versus a side, these two things are the same. The sides are the same. Whereas the bottoms are the same, and then the bottoms are the same. That's a little bit confusing, but that's only when you split the angle versus the sides. And you'll notice when you split the angle, because you always have, because you always have these like angle measurements in there that show that the angles are the same. So when the angles are the same, you're going to use even like the two sides are the same, even though they're not necessarily on the same spot, like they're both on the right or both on the left, and then the two bottoms are the same. Okay, so your green fraction will be 10 over 15, and then your yellow fraction will be 4 over 2x minus 10. We're going to set them equal to each other and then cross multiply, so I'd get 15 times 4 equals 10 times 2x minus 10, and then we can multiply. So 15 times 4 is 60, and then we're going to distribute the 10. 10 times 2x gives me 20x, and then 10 minus 10 gives me, or 10 times negative 10 gives me negative 100. So we're going to add 100 to each side. You get 160 equals 20x. Then we're going to divide each side by 20 to get the x by itself. You end up with 8. So x is equal to 8 in this case. And there we have it, how to solve special similar triangles.